Okay, our next problem, sample problem 13.7, looks at two other colligative properties which deal with molality, which are boiling point elevation and freezing point depression. And we're looking at both of these simultaneously with this solution. So boiling point elevation and freezing point depression use two very similar equations. So boiling point elevation uses this equation. Freezing point depression uses this equation. Now, basically, here's two constants that have to be given. Okay, so Kb is actually equal to 0.512 degrees C per molal. Kf equals 1.86 degrees C per molal. And again, these are both for water. They're for a specific solvent. And again, I'd have to give you that information. Molality is what we need to find. We need to find the molality of that solution, because then we're going to use that and multiply it by our boiling point elevation constant or our freezing point depression constant to find out the value that we need to add to 100, because we have a water solution. So we're going to be elevating that boiling point from 100, or we're going to be depressing the freezing point from 0 degrees. So we just need to find the molality of the solution. Molality is again defined as the moles of solute over the kilograms of solvent. Now, they actually gave us this number fairly directly. They told us that we made a solution by having 4,450 grams of water. So 4.450 kilograms. So this number was given fairly directly. Moles of solute, right? That's not given as directly. So we need to find that. But they told us that we have 1 kilogram of ethylene glycol. It's a fairly simple calculation to go from a mass of a substance to its moles if you know the molecular weight. So let's go ahead and do that. So we've got 1.00 kilograms of our ethylene glycol. Let's just go ahead and convert kilograms to grams because our molecular weight is in grams per mole. The molecular weight is 62.07 grams in 1 mole. So that's 16.1 mole of C2H6O2. So again, this is going to go up here. So the molality of this solution is 16.1 moles C2H6O2 in 4.450 kilograms of water. And that's 3.62 molal. Okay, now you note that we're asking for the same solution. What's the boiling point elevation and freezing point depression? So this molality is going to be the same for both of these. So let's go ahead and calculate the boiling point elevation. And I'm going to make sure to point out one thing briefly here. We didn't actually include an important part of this equation here, which is this Van Hoff factor, which is this little italicized I. What this really is a scaling factor for how many particles you have in solution. And it really only comes into play if you have ionic compounds or salts. So just make a little note here that I is going to be equal to 1 for C2H6O2 because it is a non-electrolyte. Okay, so this problem, we won't need to use that. We'll see in sample problem 13.9, we will need to consider that because we will be using a salt. And remember, salts are ionic compounds. They're electrolytes. They dissociate in solutions to make more moles of particles than you started out with mole of salt. Okay, if that's a little bit confusing, just look through sample problem 13.9 and you'll see an application of that. So I is going to be equal to 1 here, but the boiling point elevation is going to be 1 times 0.512 degrees C per molal times 3.62 molal. Those molals cancel, and we get 1.85 degrees C. This problem asks what are the boiling and freezing points of the solution? So we need to go one step further and not just figure out what the boiling point elevation is. We actually need to add that to the normal boiling point, which is 100 degrees C for water plus 1.85 degrees C is 101.85 degrees C. Similarly, going through the freezing point depression, we're still going to have our Van Hoff factor. Again, it will be 1, so it won't do anything mathematically here. But if we get in the habit of writing that in with our equations, we'll make sure that we don't forget it. So our Van Hoff factor is 1 for a non-electrolyte. Our Kf is 1.86 degrees C per mole. 3.62 is again the molality. 6.73 degrees C is going to be the freezing point depression. So that means that the freezing point, remember we have to subtract off that freezing point depression from the normal freezing point. So the new freezing point is going to be minus 6.73 degrees C.